Let us discuss one of the most important application of Archimedes principle, that is apparent weight of a body submerged in a liquid. To understand it, let's first consider a spring balance through which on the hook we hang a body of mass m. Say there is a spring balance Sp, and through its hook a body weight of mass m is suspended. In this situation, we know that the spring balance will have a tendency to read the tension in the connecting string in kilogram force. So in this situation, the block will be experiencing the weight mg, and the tension in this situation for equilibrium we can write T is equals to mg. So we can simply state if mass m is hanging through spring balance Sp, we can simply write its reading will be, is always given as tension divided by G in kilogram force, and here tension is mg, so this will be m kgf, that is the tension in the spring which is given us as its reading. Now see what will happen if the mass is submerged in a liquid. If I redraw the situation in such a way that again the spring balance is there, and through its hook the same mass is suspended, but the difference is now in this situation the mass is submerged in a container which is filled with a liquid of density rho L. In this situation, I take the density of liquid to be rho L. And let us consider the density of this mass should be rho S. This is the density of solid. Now in this situation, if we wish to find out the volume of weight which is suspended, this volume can be written as mass by density of solid. Now in this situation, obviously when it is submerged, a tension will be acting in the connecting string of a spring balance, as well as it will experience a buoyant force in upward direction and its weight mg in downward direction. So if we draw the free body diagram of this mass which is submerged in liquid as well as hanging through the spring balance Sp, so this can be written as mg in downward direction, and in upward direction the forces can be written as tension plus the buoyant force. And the buoyant force we know, buoyant force on block can always be written as this V rho of liquid into G, and the volume we can directly calculate like this. And for the equilibrium of object, we can also write in this situation, for equilibrium of weight which is suspended, we can write in this situation T plus Fb is equals to mg, or in this situation tension will be mg minus Fb. We can directly state as the buoyancy force is acting in upward direction, tension will be less, and if tension is less, certainly the reading of weighing balance will also be less. That's why we say when an object is submerged in a fluid, its apparent weight decreases. So in this situation we can write it mg minus Fb. Fb can be written as V rho of liquid G, and V can be given as m by rho S. So it is mg multiplied by rho L upon rho S. This is the expression we are getting. So here the value of tension will be mg 1 minus rho L upon rho S. One point you need to keep this in your mind, as this tension is written as apparent weight of object, and if we wish to find out the reading, we know well that reading is just T by G, as we have calculated the initial reading to be m kilogram force. Here T by G, when we calculate the reading, will be m multiplied by 1 minus rho L by rho S in kilogram force, that is the reading of weighing balance. So always remember, whenever a body of mass m is submerged in a liquid, Then within its submerged state, its apparent weight is written as mg1 minus rho L by rho S. This is also very useful relation we'll use in different applications, numericals and different kind of illustrations also.